In this video, we are going to see how we can give the names for alcohols, phenols and ethers. While we are using so many alcohol, phenol and ethers, we should know how we can name it. We are going to see that in this session in detail. First of all, we can see how we can name alcohols. That we studied from our 10th standard onwards, how to name alcohol. When we are talking about the common name, we can use the term alkyl based upon the number of carbon atom present in it. If it contains only one carbon atom, we can call it methyl. If it is having two carbon atom, ethyl. If it is having three carbon atom, propyl, etc. Add alcohol along with that. So, example, CH3OH. It is having one carbon atom containing alcohol. So, methyl alcohol. If two carbon atom containing alcohol, ethyl alcohol, propyl alcohol, etc. So, while giving the common name, we will be checking how many carbon atom is present. Based on that, we will use a term alkyl and we will add alcohol at the end. Now, when we are giving IUPAC name, we will be considering the respective alkane and we will remove the last E present there and we will add ol or oil into it. CH3OH, one carbon atom containing alcohol, so respective alkane is methane. We will remove last E and we will add ol to it, methanol. CH3CH2OH is ethanol. CH3CHOH CH2CH3. Secondary butyl alcohol is the common name. Butane 2-ol is the IUPAC name. We want to check where is this OH group present and we want to name it from one end in which OH group get lowest number. So we should start the naming from this end so that OH will get, the carbon containing OH group will get the lowest number, that is 2. So it is butane 2-ol, second carbon contain OH group. It is also known as secondary butyl alcohol because OH group is attached to CH, carbon with one hydrogen atom. Now, another example, CH3, CH2, CH2, CH2OH. It is also having 4 carbon atom, but OH group is attached to the N carbon atom. Therefore, the common name is normal butyl alcohol. While naming, IUPAC name, butane 1-ol. Another example, CH3, CH, CH3, CH2OH. This compound consists of a group CH3CH, CH3. That group is known as iso group. So it is isobutyl alcohol in common naming. While giving IUPAC name, we want to check where is OH group present and what are the substituent present in it. So, we will give number 1 to the carbon to which OH group is attached and we will put number in this way so that the IUPAC name is 2-methyl propan 1-ol. Another example, CH3C, CH3 twice OH. It is tertiary butyl alcohol or 2-methyl propan 2-ol. We want to start numbering from one end. So, second carbon is having one methyl group and OH group attached to it. Now, CH2OH, CHOH, CH2OH, it is commonly called as glycerol. While giving name for this type of compound, we want to say the full name propane. Then we want to say where is OH group present. 1, 2, 3, triol. That is the rule we already studied in our last chapter. Now when we are naming cyclic alcohol, we want to add a term cyclo in front of the respective number of the carbon atom. So that cyclohexanol is the name of this compound because it consists of 6 carbon atom and OH group is attached to that cyclic ring. Therefore, cyclohexanol. Next one is 2-methyl cyclopentanol. Cyclopentanol is the parent and second position is having one methyl group. So 2-methyl cyclopentanol. Now we know that in the case of OH group attached to benzene ring that we commonly called as phenol, it is the common name and IUPAC name. Last year we studied that some compounds we given a particular name and by using that we are giving the IUPAC name. So this compound C6H5OH is known as phenol either by common and also by IUPAC. So when we are attaching one CH3 group ortho to that OH group, it is 2-methyl phenol. Now we changed the position. We changed the position of CH3 group to the meta position. Therefore, 3-methyl phenol, or it is also known as metacresol in common name, orthocresol. This second one is orthocresol in common name. Now when the CH3 group moved to the para position, it is paracresol in normal naming. IUPAC name is 4-methyl phenol, where that CH3 group is present, that we will be representing as a substituent 4-methyl phenol. Now compounds with 2 OH group, dihydroxy derivatives of benzene. If it is in 1,2 position, we will call it commonly catechol. In IUPAC, we can say benzene 1,2-diol. Represent the position and tell diol. Benzene 1,2-diol. If one of the OH group move to the 3rd position, it is resorcinol or benzene 1,3-diol. If it is moving to the 4th position, it is hydroquinone or quinol. IUPAC name is benzene 1,4-diol. So we are representing the position of OH group and we will be using di, tri, etc. at the end. We will be using the full name of that cyclic part in front and we will be showing the position of OH group. Now when we are giving the name for ethers, while giving the common name, we will be using alkyl or aryl group as separate words in alphabetical order. The group which is present on either side of oxygen is used separately in the form of alkyl or aryl and they are ordered in alphabetical order and at last we will be adding ether. Example, CH3O C2H5. So, 2 groups are there, CH3 and C2H5. One is called methyl and the other one is called ethyl. When we are arranging them in alphabetical order, ethyl, methyl, ether. Second one, C2H5O C2H5. Both groups are same, so we will use di. Diethyl ether. CH3O CH2 CH2 CH3. One is methyl group and next one is propyl group and it is normal propyl, no branching. So methyl normal propyl ether. M is coming first than P, so methyl normal propyl ether. Next one, CH3O CH3 twice. That is propyl is in isomer or we can say branching is happened to that part. So methyl isopropyl ether. Now when we are giving the IUPAC name of this ether, ethers are considered as hydrocarbon derivative in which hydrogen atom is replaced by OR group or OAR group. So we want to consider OR group or OAR group together, which we will be using a term alkoxy. OR is alkoxy or aroxy. Larger R group is chosen as the parent hydrocarbon. We will check which are the R group on both sides, and we will be considering which one is larger. It will be taken as the parent. And other part, that is other R group along with O, we will term or we will call by alkoxy or aroxy term. So we will talk about that term first, then we will be talking about the parent chain. We can see CH3O CH3. Here both R group are same. So one we can take as parent and the remaining we will be naming together. So here first CH3 taken as parent, green color, underlined with green color is parent, and remaining we are calling together or naming together. OCH3, since it contains one carbon atom, methoxy. And the parent is methane, methoxy, methane. Now the second example. CH3O, CH2, CH2, CH3. So the group present on either side of O is different. One side it is CH3 and second side it is CH2, CH2, CH3. So we should take larger one as parent. Which is the larger one? CH2, CH2, CH3. That is propane. It is the parent one. Remaining we will name together. That is CH3O. CH3O is methoxy. Since this propane, first carbon itself, it is attached to O. Therefore, 1 methoxy propane, because isomers also present. That's why. CH3O methoxy, and that group is attached to the first carbon of CH3, CH2, CH3. Therefore, 1 methoxy propane. OCH3 is attached to the first carbon of CH3, CH2, CH3. Propane part. So, 1 methoxy propane. Another example. C6H5OCH3. Here 2 R group is different. One side it is C6H5 and second side it is CH3. C6H5 is the bigger one, so it is taken as parent. Remaining OCH3, methoxy. C6H5 is benzene. Methoxy, benzene or anisole. Next one, C6H5O, CH2, CH3. Here also C6H5 is the big one. It is considered as the parent. So remaining we will name together OCH2, CH3. Ethoxy, benzene. Another example. CH3O, CH, CH3 twice. 3 carbon atom containing group in one side. But in that group, second carbon or the middle carbon is bonded with OCH3 group. Okay, it is isomer of propane there, or branching is there in propane. So we want to consider it in which carbon OCH3 is attached. Here it is in second carbon. Therefore, 2-methoxy propane. Another example. C6H5O, CH2, CH2, CH, CH3, CH3. Here 1, 2, 3, 4. 4 carbon with 1 substituent, but this side is having more number of carbon atom. Our C6H5 is having more number of carbon atom. Therefore, C6H5 itself is the parent there. Now, while giving the name of the other part, we have to consider the substituent present in it. And while giving number, We want to consider the carbon very near to oxygen itself. So when we are giving the name, third carbon contain methyl group, 3-methyl butoxy, because first 3-methyl butoxy benzene, 3-methyl butoxy benzene. Another example, CH3O, CH2, CH2, OCH3. Here 2 OCH3 group is there, or 2 either part is there. So what we will do? We will check how many carbon atom is there. We can see 2 carbon atom in between OCH3 group. So that we will be considering as parent, and the remaining part we will consider as the substituent. So 1, 2. First carbon is also having OCH3. Second carbon is also having OCH3. 1, 2 dimethoxyethane. Another example. Here OCH2CH3 is the substituent and remaining is the parent. So second carbon is having OCH2CH3 attached. 2-ethoxy 1, 1. 2-methyl group attached to first carbon atom. 1, 1 dimethyl cyclohexane.